All right, thank you. I'm Peter Baumgartner, founder at Lincoln Loop. We're a Django consulting and web agency, so we build Django sites for clients and help clients with deploying and designing and tuning and all that stuff. I've been doing DevOps and sysadmin for a lot of years, so I've been deploying Django sites for a long time, kind of seen things that work, things that don't work. It's a dangerous world out there. There's lots of pitfalls, and so hopefully this talk kind of helps you avoid some of those. Real quick on my philosophy, generally we're going to try to keep things as simple as possible. The fewer moving parts, the better. The kind of less technology of somebody else that you have to depend on, the better. But we do want to maintain stability, security, performance, and observability, which is kind of a fancy word for you want to be able to see what the heck's going on with your application, logs, response times, errors, things like that. So this is the basic talk overview here. We're going to go through on the left side, we've got kind of all the things that are necessary just to get your application up onto a server somewhere. And then on the right side, we're going to talk about kind of next steps from there and other considerations you want to think about. So first up is hosting. I'm going to take this talk from kind of assuming that you don't have a lot of experience with this. You just want to get your application running on the internet somewhere. There's a bazillion different options. The analogy I'm going to use is like you're a business and you need an office to operate. So what type of office do you choose? First up is platform as a service. This is like a co-working space. You can walk in with your laptop and you're like up and running. That's it. Platform as a service, you bring your code and that's it. There's a bunch of providers that offer this. Heroku is kind of like the most popular one, but lots of other ones. Pros with this approach are they handle all the servers for you. This is kind of the original serverless platform. It's managed and monitored, all that stuff. It's supported, so you can call and ask somebody or send in an email and ask for help specific to your application stack, which is kind of unique. It also may include backing services like your database and cache. You might be able to just click a button and have one of those where some of the other options, it's not quite as easy. Cons, it's, you may be sharing infrastructure with neighbors most likely. Performance could suffer a little bit there. You generally have to kind of operate inside whatever framework they give you, so you may have less flexibility. And I put cost with an asterisk next to it because sure, the monthly cost on this option might be more, but if you account your time of setting up servers, maintaining servers, managing servers, things like that, this cost can be really attractive unless you don't value your time at all. So next up, functions as a service. This one's really popular right now. Serverless platform. This is more like maybe renting an office. You still don't have to deal with the office building, but maybe you have to figure out how to get a desk in there and things like that. AWS Lambda is the real popular one you hear about. Zappa is a great way to kind of get code up onto AWS Lambda, and other providers have similar offerings. So pros and cons here again. It's managed, monitored. They handle all the server stuff. You don't have to worry about that. It can be less expensive. The pricing's totally different. So these are generally priced per request and the amount of time the request takes. So you could spend more, you could spend less. Often it's less. In the grand scheme of things, these are really new platforms. So there may be rough edges getting Django to run on it. Some of the things that you might expect to work normally may not, or you may need to kind of jump through some hoops to do things like getting an interactive shell to run commands against. Performance and cold starts can be a concern on these platforms, so make sure you understand that before choosing one of these. Your code may not actually even be running when a request comes in, so it needs to start up, and that can take time. Kubernetes is one that everybody likes to talk about these days. I put managed on here. I would strongly recommend not managing your own Kubernetes service. The only time I think that makes sense is either you have some in-house staff who knows how to do that, or you want to learn it and understand it for whatever reason. Otherwise, let somebody else deal with managing it, updating it, all that stuff. This is more like renting an entire office building. You get lots of suites and you can do whatever you want with them. For a lot of people, I think this is what Kubernetes looks like. This is running your blog on Kubernetes. It's overkill for a lot of use cases. If you have 1 or 2 services, Kubernetes is probably more than what you need. So I would kind of steer clear of that unless there's some reason in your business or whatever that you're going in that scale. So again, with the managed options, you've got it all managed, monitored, secured. Cons are you have to know how to use Kubernetes, which is a non-trivial thing to need to know, and it's probably overkill in most folks' use cases. And then finally, unmanaged self-hosting. This is basically you get a server somewhere and you get to decide how the heck you want to set up your app, if you want to use Docker or whatever. This is super flexible. You get to do whatever you want. Cost, at least on the surface, looks low because it's cheaper to rent a server than to use something like Heroku. But again, account for your own time. Cons of this are you have to deal with everything that they were dealing with for you, security monitoring, all that. I think a big one that people don't think about in this scenario is documentation and training. So if you're in a business and you want to spin up your own unique custom stack, you may have a hard time finding other people that can manage and maintain your unique custom stack. Whereas if you're on a platform as a service, generally you can find somebody who knows it already, and if they don't know it, you can point them to somebody else's docs that are managed and maintained to move forward with that. This is kind of the building your office from scratch, like with the wood and the saws and all that approach. And again, if it's something you want to learn, if it's something you're interested in, yeah, great, go for it. If you're looking for an easy way to deploy your project, I would steer clear of this. So far, we've talked about hosting your application, but generally, Django applications don't run in a vacuum. They need a database or a cache or someplace to store files. So we call those backing services. And those often hold the state of your application, the actual data that it depends on to run. Unsurprisingly, I'm going to recommend you use managed services for these. Even more important than your application, if your application goes down, yeah, it's a bummer, but you can spin it back up. If your database goes down and you lose your data, it could be game over for your business. So let somebody else deal with making sure it's up and running, making sure it's backed up, making sure it's running the latest version, all that stuff. So every provider offers the managed services you need out of the box for the most part. Databases, object storage, which is kind of just fancy for someplace to put files. Email, generally you just need an outbound SMTP server. Elasticsearch and Redis are maybe somewhat different in that generally you're not holding your primary kind of single source of truth in Elasticsearch and Redis. So if one of those goes down, you can repopulate it from your database. So maybe not as important to use the managed service there, but still they're out there and those work really well. Okay, so that's hosting. Let's talk about configuration. The general kind of accepted way to do configuration is the 12-factor application configuration method, where you've got your application, and when you deploy, you bring in some set of configuration, and those go together and kind of make your deployment environment. The most popular way of doing this is environment variables. There are maybe some reasons you don't want to use environment variables. If you kind of read around, there are potential security concerns with environment variables. Another option, which I prefer, is a configuration file. So some sort of machine-readable file, whether it's YAML or JSON, that you can produce and your application can read in. You'll also see people doing this where they've got multiple Django settings. Here's my Django setting for production. Here's for staging, development. I'd recommend against this approach. For one, it's not dynamic, so if you want to do things like review apps where you have kind of ephemeral instances that you spin up for a branch and they live as long as the branch does and they get QA'd and then torn down, you don't really have any sort of dynamic way of managing that in this scenario. And then this scenario kind of encourages you to put secrets like your database passwords and API keys into your Git repo or wherever you're hosting your code, which is bad. Never put secrets in your code repository. And I say unencrypted because there are ways you can put them in your code repository encrypted, which are safer. So secrets, yeah, like things like API keys, database passwords, you don't want them someplace where they're easily leaked. You may not even want some people on your development team to have your production database passwords, so keep those out of your code repo. As far as options for configuration, kind of where to store your configuration, if you're on a platform as a service, generally that's baked in. You just fill out a web form or manage something on the CLI, and those variables are handled for you in hopefully a secure manner. If you're using Amazon, they have something called SSM, Simple Systems Manager, which it's not really obvious, but it can store secrets. There's a tool called Chamber that can pull those secrets out of SSM and inject them into your application, either via environment variables or the configuration file that I mentioned. If you're on Kubernetes, it's got its whole thing to do that. If you're using a self-hosted option and you have a configuration management tool, hopefully, that's managing your servers, you can often store them encrypted in there. Pretty much every configuration manager has a way to store encrypted data and decrypt it on deployment or when you push code out. And then finally, there's HashiCorp Vault. That is like a whole service that you can run that manages secrets. Again, if you're kind of just starting out, I would steer clear from this. You don't need more stuff to manage. You need less stuff to manage. If your company's already using it or something like that, then yeah, that's a great option. So how do you work with these in Django? It's pretty easy to pull in environment variables or something like that in your Django settings. But there's some drawbacks, and we wrote this project called goodconf. You can just pip install goodconf, and it will handle things like, are your environment variables, is your configuration coming from environment variables or from a file? It'll handle typecasting for environment variables. So when you read an environment variable in Python, it's always going to be a string. You can say this one's a Boolean, this one's a list, this one's an integer, and have that handled correctly. And then the last two items on this I really like are you can auto-generate both documentation and sample configurations. So generally when people start using environment variables, they kind of just scatter them throughout their settings file, and you may not know, there's no documentation as to what each one does and where they are and all that. So this handles that for you. So to use it, you just create a class. And you could put this in like a config.py file in your project, and you define all the bits of configuration. It's worth noting kind of like, so Django already has this concept of settings, but most of the settings in your project probably don't change for each individual environment. In your installed apps and your middleware and your templates and things like that, those are generally going to be the same across all your environments. I would not consider those configuration. Configuration are the things that do change. So you may want to run, you're going to want to run against different databases in all your different environments. So this is where you put that data. So you can create the class, you instantiate it, and you also, if you want to load from files, you can tell it files where it can load from. And then in your settings, you just load that config object, and you can access attributes on it for the different items in it. So that's configuration. Next up is your web server. So Django run server, manage.py run server is not suitable for running in production. There are generally two other web servers that people use. Well, there's a lot of other ones, but generally you see two, GUnicorn and uWSGI. The primary difference between those is the amount of configuration they offer. GUnicorn has about 65 different flags you can set, configuration options. uWSGI has 931. So like you really can do a lot of stuff with uWSGI, but with all that means it's more complicated. The docs can be challenging at times, and so if you're just getting started, I would recommend GUnicorn. Running a project with GUnicorn looks like this. You just point it to your WSGI module, and you give it a port, and you set a number of workers you want to run. So this is how many kind of simultaneous processes are running that can serve requests. I also strongly recommend setting a timeout whenever you deploy your application. So one of the risks here with we're running 4 workers. If you're responding to requests in 100 or 200 milliseconds, you can serve a lot of requests with just 4 workers. If you're responding to requests in 20 or 30 seconds, that becomes a really big problem. It's really easy for a single user to do a denial of service attack on your application and basically take the whole thing down. So if you have, even though when you first deploy, you may not have any slow views, as you get more data in your application, as new code gets pushed up, you may get views that kind of act pathologically, and it's better off to kill those requests up front rather than letting them run and block all your workers. So in this case, we've got a timeout of 5 seconds that any requests that last more than 5 seconds will get killed and refresh that worker to serve another request. With timeouts, you want to make sure you have some way of monitoring and knowing if that's happening. So a similar config in uWSGI. If you're using a virtual env, you define that. Other than that, it's the same things, you just different names. If you do use uWSGI, also check out, there's a project on PyPI that we built called PyUWSGI, which lets you install uWSGI as a wheel. And it's a mini Linux wheel, so you can install it on Linux without needing to compile it or install any sort of development headers or anything. So it can speed up your deployment process. Okay, so that's your web server. Next up is our assets. So Django defines assets under these 2 names, static and media. Static being your CSS, your JavaScript, media being dynamically generated stuff that happens on the server. For serving static assets, white noise is the easiest way to go. Generally, you want your application to be self-sufficient. It's easier if you don't have to depend on, I have Nginx serving my static assets. Well, on these different hosting platforms, Nginx may not be an option, and it's nice to be able to know you aren't tied to, you can move to a Lambda if you wanted, or Kubernetes or whatever. So kind of letting your application serve all its own assets is actually a benefit, I think. So white noise is really easy. Pip install white noise. You change your middleware and your static file storage, and then Django can reasonably efficiently serve your static assets. If you're using uWSGI, you can basically do the same thing. So you set this manifest static file storage. What that does, and white noise does this too, is when you use the static template tag, it will include a hash of the file and the file name. That means that file, the URL is now unique for that contents of that file, and you can cache it forever, which we'll talk about in a little bit. So that static file storage does that. You then run your collect static, you gzip everything in your collect static, and you can run uWSGI with these options. So it'll serve gzip content to browsers that support it. It'll add headers that say, cache this content forever. And then the offload threads is interesting. It can actually serve static content out of separate threads than your application. So kind of a little optimization there. So next up is Node.js stuff. Most Django, maybe not most, but many Django projects these days are using Node.js in one way or another, either to build JavaScript bundles or compile CSS. There's a great talk by Jacob Kaplan-Moss from PyCon last year, I think, that goes into this much more in depth. But the general practice is store those source files in your version control. When you go through your build process, which may look different depending on the platform you're on. If you're on Heroku, when you push code to it, it goes through a build process. You can use on Heroku, you can use a Node.js build pack in addition to your Python build pack. That'll call whatever system you're using, Webpack, Parcel, something like that, to generate all those files. And the location where those files are generated, you put that in as into your static files directories in the Django settings. And at that point, you can just serve them like any other static assets. So it's pretty straightforward. You kind of let the Node ecosystem handle all the building of the files, and the Django ecosystem handle the serving of the files. If you're doing fancy stuff like JavaScript bundle splitting, you can add Django Webpack Loader into the mix, and it can figure out where those different bundles live and how to serve them. Media is the other one. So media, this is dynamically generated content in one way or another. It might be a user uploading an avatar. It might be you generating a report specific to somebody. Django storage is generally the way you want to do this. You don't want to store these files on your file system. If you even have a file system, in some of these hosting options, you don't really have reliable access to a file system that's always going to be there. So starting by uploading this stuff to S3 or some other kind of cloud object store is the way to go. It keeps your options open for kind of how you want to host your application in the future. One caveat with this is to be careful with public versus private files. So in the use case I mentioned earlier, an avatar is public. Like anybody can see another user's avatar. If you're generating a custom report that's specific to a user, you don't want to load that up onto S3 in a public bucket because anybody can read it. So what you can do is set up multiple storages if that's your scenario, and store your objects, being careful about which storage you use to store your objects. These three settings here are what you would use on S3 if you're using S3 as a backend, which is probably the most common one. The default ACL is public read, so you can change that, and then you can use this query string auth, which lets your application generate a custom URL that expires in some point in the future. So you only give that URL to the user who you've already determined is allowed to use that URL, and then it sort of self-destructs after some amount of time. So that's how you handle private files. Okay, so at this point, we've covered all the basics. You can go live. That's kind of all you need. And no matter what, if you've done this, no matter what option you choose, you have kind of some flexibility. I wouldn't say you're very locked into a certain provider at this point. So you can. If you're just starting out, I'd recommend starting on a platform as a service. And perhaps at some point in the future you outgrow that and you move to something else, but you're in a good place to do that if you've kind of taken these steps. So the next part of the talk is going to be maybe a little bit more abstract and just talk about other kind of considerations you need to make as you run your application in production. So performance is the first one. You can't measure performance. You can't do anything with performance unless you can measure it. And the way you want to measure performance is using an APM, application performance monitor. New Relic, Scout, and Datadog all have great options. I've used all these in one way or another, and I think that's probably your best bet. There's other options, AWS if you need to self-host the data for some reason. Elastic has an APM. The next performance thing most people notice is the database. And don't be surprised if you push your project out to production and you find out it's actually slower than it runs on your laptop. Modern laptops are really fast, and there's two other things that come into play. One is network latency. So if you're comparing running your database on your laptop and your application on your laptop versus running your application on a server and your database someplace else on another server, there's latency on that network connection that is noticeable. And then the other is the size of your data set. So if you're working against 100 rows in your database in your development environment, and you have 1 million rows in your database in production, those are going to behave very differently when you query them. And 1 million rows, with 100 rows, you won't really notice if your data is poorly indexed. You will notice that with 1 million rows. So those kind of problems sort of start to pop up. More on the database. If you're unsure what database to use Postgres. It's kind of the sanest default. If you have a really good reason not to use Postgres, that's fine. If you've got a MySQL DBA in-house at your business, then Postgres probably is not the best choice. MySQL is better. I would steer clear of SQLite, which is actually a really great database, but it sort of breaks this idea that you can potentially horizontally scale your application across multiple servers at some point in the future. With SQLite, you're sort of tied to the file system where the SQLite database lives. If you want to kind of tune your database further, the first and easiest one is this connection max age setting. By default, Django will open up a new database connection for every request that has to do SSL negotiation potentially, and also authenticate with the database. It's not uncommon to see 20, 30 milliseconds spent doing this. So setting this will let it share that connection with multiple requests and save some time right off the top. Next up is reducing queries. So your APM should show you how many queries you're running on any individual view. If you're running hundreds or gasped thousands of queries, you have a problem. So things like select related and prefetch related can generally help with that. A lot of times that's just quick change on a query, and you can get, if you're doing something in a for loop, it's easy to go from 101 queries to 1 query. The Scout APM actually has a really good tool for detecting these sorts of situations where these options will help. And then finally, I don't have time to go into it, but database indexes are huge. So if you have a query that's running very slowly, it's very possible that you just need to add an index to a specific field you're querying on. And you can use DB index and index together to add those. My unsung hero of performance in Django is template fragment caching. This is where you just take a section of your template and you wrap it in this cache tag, and you tell it how long you want to cache it for, and it will serve that out of cache after it's been generated once. Here's an example from a project I worked on this year where their requests were originally in the 2-second range. We identified this is a graph from New Relic, that most of the time was spent actually generating the navigation on their site, which didn't really change a whole lot. And it was really easy to, it was actually difficult to kind of cache and validate it because the data came from so many different places. But wrapping it in a cache tag that lasted for 2 minutes and saying, hey, if you make a change, it might take a minute to show up in your navigation, and it was a 10-minute fix. That was a pretty reasonable trade-off to get down to 200 millisecond response times. Next up is the CDN. So CDN is something that sits between your users and your application, and ideally very close to your users. You may hear people refer to this as the edge of the network. What a CDN can do is take content that your application's serving and store it at the edge near the users. And same thing with the database network latency, cut out the network latency of potentially going halfway around the world. If you see anybody from Australia or New Zealand, ask them how their general internet browsing experience is. It's much different than what you might be used to if you're from the States. So CDN providers, this isn't something you self-host. It requires being kind of globally available. Your hosting provider probably has one if you're on like one of the big clouds. Third party, there's Cloudflare and Fastly. Cloudflare has like a surprising amount of functionality in their free version. It's a really great option. The easiest win here is your static files, because we earlier gave those all a unique URL. You can tell your CDN to cache those forever. Users they're gonna hit the CDN once, and then they will be served very quickly to your users. You can also potentially cache Django responses. So if you have pages that don't change at all or don't change often, you can cache those at your CDN as well. How you do this depends on the provider. It might be that you send up a specific header with the response that says it can be cached. It might be some configuration you do within the specific CDN provider. So that's a real quick overview on performance. Next up, security. I almost feel bad putting this in because there's a lot more to security than this, but this should at least help you get started. With your code, make sure you're monitoring your dependencies for vulnerabilities. And as time goes on, we tend to get more and more dependencies, especially if you're depending on anything in the Node ecosystem. So doing this in an automated fashion is really the best way. GitHub security alerts are awesome for this if your code's on GitHub. If not, I think some of the other repository providers offer this, or third parties that offer this, that will basically just scan your requirements and say, hey, there's a known vulnerability for this one. The other step with this is you have to actually act on that and update that requirement. Next up is using a lock file. So having this kind of comes out of the box with the NPM and Node stuff. If you're using pipenv or poetry to manage your dependencies, it's also coming out of the box. If you're just using requirements.txt file or something, you can use pip tools. Has a command line tool called pipcompile, which will take your dependencies and create a lock file basically of all of them. So the goal here is a couple of things. One is you're checking hashes. So if you say I'm depending on Django, you lock that down to I'm depending on Django, and this should be the hash of the package I'm downloading. And if for some reason you download a package that does not match that hash, then you fail and throw it out. There's a problem. Somebody maybe is hacked into PyPI, or there's a rogue maintainer or something like that. You want to know about these events and don't want to just willy-nilly grab packages from the internet. And then the other one is subdependencies. So you are generally going to define the dependencies your code depends on, but those dependencies have dependencies, and you want to lock those down as well. That prevents kind of the ground from shifting underneath you as you deploy your project in different environments, and also provides that hash checking for those. And then finally, if you are dealing with particularly sensitive information, personally identifiable information, things like that, consider an external code audit. They're expensive, but they're not outrageously expensive. If you're running a business, you should be able to afford to do one of these. So they may be doing analysis of your actual code itself, or some sort of penetration testing of your site from outside. Next up is your environment. So these are kind of, you could have really secure code and still run it in an insecure manner. So I recommend debug false always. You always set the debug setting as false. It doesn't matter if it's a development environment. If it's on the internet, it's debug false. And developers sometimes complain about this and say, oh, I want to be able to see if there's an error, what happened. There's much better ways to see errors than the debug 500 page. I'll get to those in a minute. The manage, check, deploy will check some of the common security settings in Django and make sure that you've set them properly for a public environment. And then finally, there's observatory.mozilla.org. It has a lot of overlap with this check deploy one, but it will basically check that a lot of the security settings in Django are headers that for things that might prevent clickjacking or something like that. This observatory will actually make a request into your app from the internet and make sure that you've got those all set up properly. Authentication. So Django's admin's really awesome and really easy to use, and putting it on the internet is probably not a really great idea. If you have a Django admin that you're using, the best option is to put it behind a VPN, put it behind a firewall, somehow lock it down so the general internet public and angry bots cannot sit there and hammer away at the login page trying to figure out a valid account. In some scenarios, that may not be possible or may be difficult. In that case, rate limit it at a minimum. Cloudflare can offer rate limiting. There's lots of other ways to do it. You can actually do it in Django itself. I would kind of use that as a last resort, but it's possible. And then multi-factor authentication is the other one. So if you have to have it on the internet, use some sort of multi-factor authentication. So if somebody gets their password, lost in a database hack or something, somebody can't use it to log in. I haven't used this Django two-factor auth project myself, but it appears to be designed exactly for that. I have done things where just replace the default authentication with some service that you control, AWS Cognito or like a Google Suite, and then you force anybody who's an admin to do multi-factor auth at that place. Additional things to consider, like I said, there's a ton in the security world. This scratches the surface. SSH, if you are running servers, are your SSH endpoints secure? Are the keys secure? Your platform web console is a real easy way to totally destroy your site. So if somebody has a weak password there, it's kind of game over. So definitely make sure people are using multi-factor authentication there. Domain registrars and emails are a good kind of backdoor method to get into your website, hacking your email and then triggering a password reset or something like that. Backing services is a common one you hear. So, like accidentally public S3 buckets, accidentally public MongoDB databases. Make sure, if you can, those services are private. If you're on a platform where for some reason you can't have them be private, make sure they're password protected and they're using strong passwords, and probably consider rotating your passwords. And then finally, APIs. If you're using the AWS CLI, Kubernetes CLI or something, are those keys secured? Are those rotated periodically when a developer leaves? Are they revoked? So that's security. Next up is observability, which covers a lot of things. Covers logging, covers error reporting, covers kind of tracking metrics, monitoring, all that stuff. So first up is error reporting. Django has this really awesome feature where it will email you whenever there's an error on your website. This is awesome when you have 10 users hitting your website. It's not so awesome when you have 10,000 users hitting your website. Sending out 10,000 emails will both make your application servers very angry and probably your email provider very angry and might get you blocked. So in general, I recommend kind of flipping this off and not counting on it in production unless you're running a very, very small site. Use something like Sentry or Rollbar. These are much better tools for this. You'll get much more information. Sentry is the one we use. It's awesome. It's built on Django. It's open source, but use their hosted version. It's not that much, and it will save you a ton of headache. This is what I recommend instead of running debug false as well. Generally, you can run lots of different projects or lots of different environments on a single instance of this. So you could have your dev, QA, production, all these different instances all reporting to Sentry, and your developers can get the error reports there. Logging. So, historically we log, data into a server, a file on a server. You can go read that file. This breaks down when you don't have a server or when you've got many servers. So look into how you can kind of aggregate those logs and access them all in a single location. AWS CloudWatch, Google Stackdriver, it's generally built into the big cloud platforms. I find those sufficient, I guess. They're generally kind of clunky in my experience. I've used Datadogs quite a bit, which I don't know, you've probably seen me mention this service a few times. They really have like a good suite of tools across the board here, and it's kind of what they focus on, so that's a good option for collecting all these logs. If you're using platform as a service, it's probably already handled for you, at least in the short window. You also want to kind of consider how much time you need these logs for. You might, if you've got, for compliance reasons, you need to store this for 30 days, make sure you're doing that, because some, if you're using like a Heroku or something, you may not have any history in the logs. And next up, monitoring and alerting. Again, this is like a little bit embarrassing. There's like whole conferences around this topic, so this is just like, super brief intro. But a few different ways to look at this. If you're doing any sort of self-hosting stuff, you want to monitor your internal stack. How is the CPU on your servers? Are you using too much memory? Are you running out of disk space? Is something thrashing? Like, you want to know that stuff. Internally, you can be all well and good, and still, for some reason, no traffic can get to your website. So you also want to have external tests, something that's hitting your website potentially from multiple locations, saying, yes, you are actually up and operating properly. And then you need to alert on this data. So if you're running a larger team, you've got like on-call schedules and stuff. PagerDuty and OpsGenie are great. We use OpsGenie and are happy with it. If you're a single person, just sending it to Slack, sending it to an SMS, sending it to an email might be sufficient. And also be careful of kind of monitor fatigue or alerting fatigue here. You don't want to be paging people at 3 a.m. Because of something that's not really taking the site down and maybe not a major problem. So generally, my philosophy is, page people when either the site's down or you have like very elevated error levels. Otherwise, put those into a Slack channel or something and let somebody check it when they're fresh and at work, and can handle those kind of important things to look at, but maybe not site is down level important. And that is everything I have. So thanks so much for coming. Again, I'm Pete Baumgartner. My slides were done by Joni Trithal at YupGup. She's awesome. She did the DjangoCon stuff as well, I believe. And I have a booth out here with Lincoln Loop. So if you have any questions, I don't know if I'm going to have any time right now. If I do, I'm happy to take some. Otherwise, come see me at the booth. I love talking about this stuff and happy to let you prick my brain or try to answer anything I can.
Cool.